Hey, how's it going? Before we jump into the content, I just want to take a minute to thank you for stopping by the channel and checking out the content. If you like this content and you want to support more content like it, then make sure to subscribe to the channel and like this video. You can also check out the YouTube membership program and cybertrainingpro.com, where I put practice exams and other things that I couldn't put on YouTube. Again, regardless of how you support the channel and my content, I couldn't be more appreciative. Thank you so much, and let's get into the content. When it comes to networks and their geographic reach, you need to be aware of the different types of configurations and how far they reach. It's possible that before even starting this course, you knew what a LAN or a local area network was to some extent. If you aren't, the quick version is that a LAN means that all devices are local, and this is like what you have at your home or in a single office building. In organizations today, an extremely common form of a network is called a WAN, or a wide area network that connects computers over a large geographic distance, which could be different states or different countries across the world. You might even hear of something called a CAN, or a campus area network, which is referred to as a WAN, even though it's really just a LAN on a large campus like at a university or a large building site. Many long-distance connections that connect cities across the United States, for example, use a technology called Sonet, and its original purpose was to handle specific heavy-duty circuits like T1 lines. Sonet, or the Synchronous Optical Network Standard in the United States, and its European comparable called SDH, or Synchronous Digital Hierarchy, were developed in 1987 for handling interconnections of long-distance internet routers. This allowed all the voice and data carriers to connect to each other and made the connections much less expensive than they previously were. Now, Sonet operates at the physical and data link layers of the OSI model, so layers 1 and layers 2. You might also see optical carrier, or OC, standards when referencing Sonet, and that denotes the optical data carrying capacity in bits per second of fiber optic cables. The speeds can range anywhere from 51.8 megabits per second all the way up to 39.8 gigabits per second. What if you want more throughput? Bidirectional wavelength division multiplexing, WDM or BWDM, or the newer version that's called dense wavelength division multiplexing, DWDM, enables single mode fiber to carry up to 150 signals that use different wavelengths. It's typically the least expensive option when compared to adding more fiber lines, and it can work on long-distance fiber Ethernet connections. Coarse wavelength division multiplexing, CWDM, is another useful technology that can carry multiple wavelengths over long distances. The downside is that it has a 60-kilometer limitation. It's important to understand that Sonet is being replaced today by faster speed Ethernet connections that are continuously improving. Like anything, if you want something dedicated to you or your company, it's going to be more expensive. With that being said, leased lines, which are dedicated WAN connections, are definitely popular with companies so that they can limit their attack surface against hackers. One of the issues with leased lines and data that has to travel over long distances in general is that there's a lot of information that has to be exchanged to determine where that next hop is at. MPLS, or multi-protocol label switching, is a platform-agnostic labeling system that improves performance over long distances compared to an IP network. We see MPLS used in a lot of service providers. MPLS adds an MPLS label between the layer 2 header and the layer 3 header. You can see on the screen what an MPLS header looks like with the label. The label is a unique identifier that MPLS routers use to determine how to move data. Experimental bits are a value used to determine the importance of the labeled packet so that it can be prioritized over other packets. Bottom of the label stack is used if the packet has multiple MPLS labels. The single bit value of the initial label can actually be set to 1 in this case. Time to live determines the number of hops before it expires and is discarded. Now, one of the big ideas with MPLS is that routers can use the header information to route packets quicker, and it allows for more efficient prioritizing of packets with quality of service and managing the overhead of routers. MPLS networks can also provide internet connectivity for satellite business locations using a public-facing router at the telephone company's central office called a backhaul connection. This way you get the security of MPLS, but the connection is probably going to be slower than a direct internet connection. MPLS connections unfortunately are expensive to set up, so why not use an internet connection with another protocol like SD-WAN? Software-defined wide area networking, or SD-WAN, enables traffic over the internet to also use several features of MPLS, including efficient addressing and the ability to route large amounts of traffic. Metro Ethernet networks or Metro optical networks take advantage of fiber optic cabling that's already installed into a city, combined with their own Ethernet to create a private network. These metropolitan area networks or MANs don't connect to the internet, so that's one less worry for your security team. But of course, if you do end up connecting to the internet, you're going to have to secure those connections. The cost is also significantly less with Metro Ethernet than it is to implement something like MPLS or SD-WAN networks. Last mile technologies are what's used to go from your local service provider to you, your house, or your office building. These are the technologies that you're probably most familiar with as an end consumer of these services. DSL or digital subscriber lines are fully digital and dedicated connections that don't have a phone number associated to them. DSL connections start out coming from a public switch telephone network or a PSTN connection, and they even use the same RJ11 jacks like your normal telephone. There's two types of DSL that you need to know about. We have SDSL, which has the same upload and download speeds and can provide speeds of up to 15 megabits per second, but usually they're throttled to slower speeds than that by your provider. Then we have ADSL, which can provide different upload and download speeds, typically with faster download speeds and upload speeds, because let's face it, downloads make up the majority of most internet traffic for people and businesses. ADSL speeds can reach up to 15 megabits per second for downloads and up to 1 megabit per second for uploads. ADSL is also less expensive than SDSL. General features of DSL include that there's no need to create new connections because you can use your existing phone lines to run both the internet and to make phone calls. With DSL, all connection points, so for example your house or your business, have the same distance requirement, and you can't be more than 18,000 feet from the central office of the provider. At these central offices, the provider uses something called a DSL access multiplexer to connect lots of customers to the internet. DSL modems are considered smart jacks that allow your internet service provider to test your connection. In order to install DSL, because of how these lines work, you need something called the DSL POTS filter to separate the signals so that your phones will still work. For internet, you'll have a DSL modem and possibly a router for all your systems to connect to. In order to connect, for more recent versions of DSL, they use point-to-point protocol over Ethernet, or PPoE, which is designed to encapsulate PPP frames into Ethernet frames. The main point here is that you have to log in with an account and a password to access the network. You'll likely have built-in support for PPoE in your router so that you can enter a username and password into the router configurations on the web interface. Eventually, cable television providers wanted in on the action too, so they developed broadband access to transmit the signals over the existing wires and compete with DSL providers. The biggest benefit with broadband access is that you can reach impressive speeds. We're talking anywhere from 5 megabits per second all the way over 1 gigabit per second. The actual speeds are going to vary by the provider, but it's way faster than DSL. The hardware that you're going to need for broadband access is pretty simple. You need a cable modem either from your provider or that you purchased and had them activate, and your coaxial cable from the wall connects into the modem. Then you'll have an Ethernet cable coming out of that modem for your computer or your router. Just like with DSL providers and the central office, you'll have a coaxial cable connecting to something called a head-end that connects into your cable company's network. These networks use a protocol called Data over Cable Service Interface Specification, or DOCSIS, and the current version of DOCSIS is 4.0. Satellite's another internet connection for those living in remote areas. Now there's two types of satellite connections that you need to know about. You have one way that allows you to download via satellite, but you need a regular phone line or a dial-up modem to upload. And then we have two-way, where the satellite can handle both the uploads and the downloads. Satellite connections require an antenna, like a satellite dish for television, and that connects to a modem, which then connects to your computer. DSL providers over the last several years have been disappointed with how popular cable modems have become, so they've really started to push out fiber connections in homes. Fiber offers tremendous speeds. We're talking about 1 gigabit per second upload and download, which is so fast. To make things affordable, providers are using something called a passive optical network, or a PON architecture, which uses a single fiber connection to a neighborhood switch, and then individual fibers run into each house or final destination. Chances are good that if you're in a major city, that you can get fiber connections either right away, or a technician can come out and wire up your house and get you going within a few hours. Cell phones are a part of everyday life in most locations around the world, including where you're probably watching this course from. I'm guessing that you've heard of 4G and 5G. Well, those actually refer to the generation of network and not necessarily the technology associated with it. Let's talk about some of the technologies that cellular connections use. Global System for Mobile Communications, or GSM, was the first group of networking technologies used in mobile devices. It relied on something called Time Division Multiple Access, or TDMA, that enabled multiple users to share the same channel at the same time. GSM devices use the popular SIM cards that you might have seen, or they're also called subscriber identity modules that could store contacts and was basically what told your phone how to connect. You could even take the SIM card and switch it to another device and be up and running right away. GSM is considered a 2G technology or a second generation technology, and one of the last improvement variations was called enhanced data rates for GSM Evolution or Edge, and you could get speeds of up to 384 kilobits per second. CDMA, or Code Division Multiple Access, came around a little bit after GSM, but it used a spread spectrum form of transmission and enabled users to share a single channel by splitting up that channel into slices, and each user had a different frequency. CDMA wasn't compatible with GSM. For example, you couldn't take an old GSM phone and swap that SIM card into a CDMA phone. This was also an issue because a lot of the world was using GSM despite CDMA being a superior technology. CDMA was also considered a second generation technology. Ever wondered how 3G came to be? In the late 1990s, a standard called International Mobile Telecommunications 2000, or IMT-2000, was released by the International Telecommunications Union, ITU, to support full internet connections and other improvements like support for multimedia messaging. Both GSM and CDMA made improvements due to IMT-2000, and initially just being able to support this standard was considered 3G. Evolved High-Speed Packet Access, or HSPA+, became the final 3G standard with a maximum speed of 168 megabits per second, but you'd be lucky if you actually got over 10 megabits per second. In early 2010, devices started rolling out to support networks with long-term evolution, or LTE technologies. LTE ended up being adopted as the actual 4G technology to use. LTE had speeds of up to 300 megabits per second download and up to 75 megabits per second upload. Just like GSM devices, LTE devices use a SIM card, but it's actually smaller and considered a nano SIM. Funny enough, I used to work for Verizon Wireless when LTE started rolling out, and I remember that other carriers like AT&T were advertising 4G networks, but in reality, they hadn't even adopted LTE. Most standard consumers had no idea the difference in technologies. Fifth generation, or 5G, is the successor to 4G, and it began rolling out in 2019 with even faster speeds. 5G has 3 bands, low, medium, and high, all using different frequencies. Low runs at 600 to 800 megahertz, similar to 4G. Medium runs at 2.5 to 3.7 gigahertz, and high runs at 25 to 39 gigahertz. The idea with the ranges is that the higher the frequency, the higher the speeds, but the shorter the range. Overall speeds range, but you can expect somewhere between 30 megabits per second to 1 gigabit per second. That is insanely fast for mobile devices, especially compared to where things were at not that long ago. Remote access utilizes LAN or WAN technologies to allow a computer to access file and resources all around the world. Literally, these kinds of connections make it feel like the server's right next to you. Remote terminal is a connection on some system that isn't physically located close to you as a user, but you're logged in as if you're sitting right there in front of that system. Telnet and SSH are very common protocols to use for remote terminal access. With these types of connections, one system acts as a server, which is your distant system, and the other system is a client. Have you ever seen the Remote Desktop Protocol, or RDP, on a Windows system? This uses port 3389, and it provides a graphical user interface, and is literally the same as if you're logged into the system sitting right in front of it. If you're connecting to a Windows Server system, it can provide you a secure tunnel via HTTPS for a Remote Desktop Connection, or RDC. The server itself is running a Remote Desktop Gateway, or RDG, role to use TLS for security. There are other third-party terminal emulation programs that can run on several operating systems. A good example that's free is VNC, or Virtual Network Computing. These types of connections can allow in-band management that's fast and inexpensive, but the systems have to fully load their operating system to work, and they don't allow for as much security as a dedicated alternative connection. Lots of servers allow for out-of-band management using lights out management, or LOM, capabilities to address these issues. Virtual private networks, or VPNs, create encrypted tunnels between a computer and a remote system or network for securing data traffic. For example, if you work at a company and you're issued a company laptop, you probably can connect to the VPN using your home internet which makes it seem like you're directly connected into your company's Ethernet wall jack. We call this type of VPN a host-to-site VPN. VPNs use endpoints to connect each other, and they're at both ends of the VPN tunnel. So for example, your laptop would be one endpoint, and then at your company you would have some dedicated box or some system serving up as the other endpoint. With VPN software that's installed on your laptop, this creates something called a virtual NIC, because for example, your home network is going to assign you one IP address for your computer, but the virtual NIC is going to need an IP address with the same network ID as computers in the LAN back at the office. Two other types of VPN configurations that we won't talk much about are going to be site-to-site VPN, and this is where connections are used to connect physical sites instead of an end-user system and the corporate network. And host-to-host VPNs are a direct connection between two machines using VPN software or hardware. PPTP and L2TP are common layer 2 protocols used with VPNs, and IPsec is used to handle encryption needs. PPTP VPNs, or point-to-point tunneling protocols, are an advanced version of the PPP protocol that Microsoft uses to handle VPN connections. PPTP is specifically placed on the client and server endpoints. Windows Server runs a special remote access server program called Routing and Remote Access Service, RRAS, and the client uses the Add a VPN connection in the control panel. Most operating systems today include a built-in VPN client that supports PPTP and other VPN protocols. Layer 2 tunneling protocol takes the great features of PPTP, a Cisco protocol called Layer 2 forwarding, and added support to run almost any type of connection possible, from telephones to Ethernet and others. Instead of the endpoint at your corporate location being a server program, this makes it a VPN-capable router called a VPN concentrator, which is a VPN head-end. L2TP uses IPsec for almost all its security needs, so really it's like L2TP and IPsec VPN, and it's supported by every operating system's VPN client. This is a good time to quickly talk about split tunnels versus full tunnels. Now, split tunnel VPN connections are when traffic destined for private networks uses the VPN and the rest of the traffic uses the local system's internet. For example, your home internet connection. So for example, if you were trying to access your corporate network shares, that would use the VPN. And when you try to access YouTube, that would use your home internet connection. Full tunnel VPNs force all traffic to go through the remote connection, but traffic is going to move a lot slower. Let's get back to talking about VPN tunnel technologies. SSL or TLS VPNs are something that Cisco VPN hardware allows, and it's a form of clientless VPN where systems can actually use their regular web browsers and the traffic is transported over a secure channel. There's two types you need to know about. SSL portal VPNs present a client with a web page, and then anything linked on that web page is accessible, so email, web pages, and so on. SSL tunnel VPNs require an active control like Java, but they also allow the clients to have greater access. This requires the user to have sufficient permissions to run active browser controls. Datagram TLS VPNs optimize connections for delay-sensitive applications like voice or video using UDP datagrams instead of TCP segments for communication. Dynamic multipoint VPN enables direct VPN connections between multiple locations directly. For example, instead of routing all the traffic from remote office locations through headquarters, each site can connect directly to each other. Other common VPN technologies today use IPsec instead of L2TP. Cisco's iOS EasyVPN and Cisco's generic routing encapsulation GRE are two common examples. DMVPN even uses multi-point GRE or MGRE protocol for dynamically configured tunnels and tunnels to go to multiple destinations. Let's talk about some of the common issues that you might see when dealing with WAN connections. First up, loss of internet connectivity. Think about all the things that you need to connect to the internet. You need a public IP address, either using static configurations or through NAT. You need the correct subnet mask, default gateways, and DNS servers. Common tools to troubleshoot connectivity issues include ping, ipconfig, netstat, and NSLookup. What about interface issues? Think about the path that the data takes from your computer to get onto the WAN. Can you reach your local switches and routers? Are all the interfaces working on those? What about your modem? Are all the connections plugged in and working? Traceroute's a good tool to see if the data is actually getting outside of your network. What about DNS issues? It's totally possible for a DNS server to go down, but do you have the correct DNS server IP address configured? Are the DNS records for the resource actually correct? What about interference? Are there any new appliances or lighting that's causing electromagnetic interference or EMI? Are you using shielded cabling, boxes, or conduits?